Okay, the directions here say rationalize. So when we think rationalize, what they really want us to do is to get rid of the root in the location it is. Sometimes we rationalize the numerator, sometimes we rationalize the denominator. In this example, obviously we would rationalize the denominator because the root is in the denominator. In other words, we don't want any more roots in the denominator. When you rationalize, often you're going to end up with the root in a different position. If you rationalize the denominator, then you're going to end up with a term that has a root in the numerator. Okay, so this is an expression. If we have an expression, we're allowed to always add 0, and we still have the same expression we started with. It may look a little different. We could add 0, or we can multiply by a number 1. I'm going to pick a fancy number 1, and multiply by number 1, and I'm going to be a little creative on the number 1 that I pick. I'm going to multiply by the same thing over itself, and I'm going to multiply by something called the conjugate. 5 plus square root of 11, 5 plus square root of 11. So let's do some notes over here. A minus b and a plus b are called conjugates of each other. And notice when I multiply the numerator and denominator by the same thing, I am multiplying by number 1, so that's why I call it fancy number 1. But when I'm going to do this expansion in the denominator, the first term is the same, it's a 5. The back term changes signs. So I have a minus b, that's this first one, times a plus b. So when you multiply a minus b times a plus b, hopefully you remember the rule. You can FOIL it out, or you can remember that it's a difference of two squares. A squared minus b squared. If you FOIL it out, you get a squared plus ab minus ab minus b squared. And notice the ab terms will cancel because they have the same term but different signs. So we're trying to get rid of the root in the denominator. So if we try to square this, we're going to have trouble. But if we multiply a minus b times a plus b, notice we are squaring the front, putting a minus sign, and squaring the back. Okay, so I'm just going to kind of write that. Square the front term. Write your minus sign, and then square the back term. That's our steps. Okay, so let's do that. We're going to do 8 times 5 plus square root of 11. We're going to distribute. So we get 8 times 5 is 40, plus 8 square root of 11. And then in the denominator, you have a minus b times a plus b. You could always FOIL it. But notice 5 is the front of both of these. And there's a root 11, but one is a negative root 11. The other is a positive root 11. So that's like negative b and positive b. So we're going to square the front. So 5 squared is 25. We're writing a minus sign, and we're going to square the back. Well, the square root of 11 squared is just 11. Does that make sense? So our numerator is 40 plus 8 square root of 11, and our denominator is, what, 14? Now, you could simplify this a little bit. You could reduce this. If you notice, you have a 40, an 8, and a 14. There is a greatest common factor among all of those, so we can reduce this if we want to. 40, 8, and 14 have a greatest common factor of 2. So you can factor out a 2. 2 times 20 plus 4 root 11. And then 14 is 2 times 7. So the 2's cancel. And you're left with 20 plus 4 square roots of 11 over 7. So most of the time we want the most simplified answer. Depending what you're doing, you may be asked just to do the work and not simplify it completely. But one thing I want to point out is we rationalize this, which means the root is no longer where it started. The square root was in the denominator. Notice there's no root in the denominator. There is only a root in the numerator. Okay?